Right. Hello again. We're going to solve system of equations by elimination method. And this is going to be, the first step to do is you basically choose a variable that you would like to eliminate first. Okay. And when you do that, we want to try to pick the one that's easiest. Sometimes there isn't. But if you don't have any flexibility available to choose, then we just start the process. So in this case, you notice that one of the equations from the system has a fraction, and it is much easier if we eliminate fractions before we go ahead and choose a variable to eliminate entirely. All right, so my recommendation is to look at the second equation, 7/3 x plus y equals -5. It's probably going to be a good idea to multiply the whole equation by 3. Since there's only one fraction there, the denominator is 3. So if we go ahead and do that and multiply the whole thing by 3, then basically what happens is you get a cancellation of the denominator with what you're multiplying, and you're just going to be left with, 7x plus, and then 3 times y is 3y, and then 3 times -5 is -15. Okay, so you're essentially distributing, the 3 with this, and then you're going to do that with this, and then with that. But the 7/3 times 3 will cancel, the 3's will cancel, and then you're just left with 7x plus 3y equals -15. And now you have a system where we're just going to kind of write together here. Okay, so that will be 7x plus 3y equals 4. The other one is 7x plus 3y equals -15. Okay, so we took care of the fraction, we eliminated it. Now there's something a little bit easier to work with. You notice how both equations have the same coefficients, okay? So now we just choose a variable, and in this case it really doesn't matter because all the coefficients are the same. So I'm just going to choose, for example, maybe we can multiply by -1. Okay, multiply one of these equations by -1. I'm just going to pick the bottom one. It really doesn't matter. Okay. And you're probably saying, well, why am I multiplying by a -1? Well, in order to cancel a coefficient, they not only have to be identical, but they have to be opposite signs. So 7x and 7x, for example, will not cancel if you add them up. You're going to get 14. And same thing with the 3y's. You're going to get 6y if you add them up. So in order to add them up and cancel them, okay, we are going to choose one of those equations and multiply by a -1 so that we can make one of those equations with a -7 and a -3. So that way when I add them up, the x and the y's will cancel. And they will cancel at the same time because all the coefficients are the same. So if we just make one negative, then, they're going to cancel. So what this is going to have is the first equation stays the same. Okay, and now look at the second equation. When you distribute this negative, okay, then that's going to leave you with a -7x. A negative times a positive 3y is a -3y. And a negative is a positive 15. So now when you add these up, okay, when you add these up, all right, you notice that the 7 minus 7, they're going to cancel. 3y minus 3y cancel. And then 4 plus 15, that's going to equal, now this is all going to be 0 on the right side, and that's going to equal 19. Now, you and I know that that's not a true statement. 0 does not equal 19. Okay, so basically what happens here is that this is a false statement. And that's going to give you no solution. So anytime that you get a situation where both variables cancel out and you're just left with something equals a different number, okay, like in this case 0 equals 19, you know that that's a false statement. So your answer is going to be no solution. Okay, that's your final answer, no solution. Okay? And that can happen sometimes. It won't happen all the time, but it can happen. So that's something to keep in mind. All right? All right, the next example is that let's say you had 2x equals minus 5y plus 1, negative 10y equals 4x minus 2. And we want to go ahead and use elimination. So what we want to do is we want to choose a variable to eliminate. Okay? Now, before we do that, we want to make sure all the x and y terms are on one side. Okay? This is not the case. So I'm not going to quite be able to eliminate it just yet. I need to line up all the x terms and y terms on one side of the equation, and all the constants should be on the other side. So I am going to convert the first equation. Okay, if you look at maybe I can do it over here. Okay, so if you look at this equation, all right, and you know what? Yeah, that's okay. 2x equals minus 5y plus 1. I am going to go ahead and bring the 5y over to the left. And that way, this will cancel. And then you're just left with, 2x plus 5y equals 1. Okay? And then this equation here, it's probably going to be a good idea to probably subtract the 4x on both sides. And that way, these cancel. Now you're just left with, instead of writing negative 10y minus 4x, I'm just going to write the minus 4x first. Then the minus 10y, that equals negative 2. Okay? And if I go ahead and write these under each other, then, the first one is 2x plus 5y equals 1. The second one is minus 4x minus 10y equals negative 2. So in some instances, you may have to rearrange the equations and get them into standard form, and standard form has both the x and y terms on one side. And then just make sure that they're underneath each other so that you can go ahead and cancel or start the process of choosing a variable to cancel or eliminate and go from there. Okay? Because sometimes they're not always presented in the standard form. All right? So now that we did all that, okay, we want to go ahead and start choosing a variable to eliminate that we think would be a good choice. Okay? There's not too much of a difference. There's really no one easier one than other. I mean, the coefficients are all different, and so we can go ahead and choose one. If you want to choose the x, that might be a little bit, we can do that. We can choose the x to eliminate, and therefore I'm going to multiply the whole equation by 2, and that way it looks like a 4x, and then since the other one has an opposite sign already, we'll just times the whole thing by a positive 2. We don't have to worry about a negative in there. So when you do that, okay, then this is going to give you 4x plus 2 times 5y is 10y. And don't forget to multiply it by the 1, which is going to be a 2, okay? 2 times 1 is 2. Because you have to multiply everything in the equation. And then the second one just stays the same, so we'll just copy it under here. And if we go ahead and combine these, okay, then what happens to 4x minus x? Well, that cancels. What happens to 10y minus 10y? That cancels. What happens to 2 minus 2? That cancels. So you're literally left with nothing on both sides, but that is a true statement. Okay? That is definitely a true statement. And therefore, okay, you have infinitely many solutions. Okay? That would literally be the answer. Okay? So sometimes you'll get a situation where the variables will cancel and you either get a quantity equals the same quantity. So if you have any two numbers that equal each other out, or equal each other on each side, then it's infinitely many solutions, like 1 equals 1, 0 equals 0, 10 equals 10, you know, like something like that. Okay, so that's another possibility that you could see when solving system of equations. Okay, you can either get no solutions or you can get infinitely many solutions. And then there is another possibility, which we'll do now. And we have negative 5x plus 3y equals minus 12. Okay? And then the second one is just x plus 7y equals 10. Right? So look at both equations and choose a variable that you think will be a little easier to eliminate. If you look at the coefficients of y, they're both different, so that means you're going to have to multiply both equations by something in order to make those coefficients identical. And that's going to require a little work. However, if you look at the x variable, notice that all we have to do is multiply the second equation by a positive 5, and then you'll have negative 5x plus 5x, and that will eliminate your x variable right there. So it would probably be a good idea to choose to multiply the second equation by positive 5. Okay? So when you do that, all right, remember the first equation stays the same. All right? And then the next equation, if you distribute the 5 here, here, and here, then 5 times x is 5x. 5 times 7 is 35y. And then 5 times 10 is 50. And now you have a system of equations where if you combine these, you will go ahead and cancel the x variable. 3y plus 35y is going to give you, whoops, sorry about that, is going to give you 38y minus 12 plus 50 is 38. And then if I divide both sides by 38, then the coefficients of 38 cancel, and I'm just left with y equals 1. So that is one of my solutions. Well, I shouldn't say solution, it's one of my solved variables. I still need to solve the equation for x. Okay? We only solved for y. So why don't we just pick one of the original equations? Okay? So the next step is choose one of the original equations, right? To plug in y equals 1, or substitute y equals 1. Let's pick the second equation. It seems like a little easier to work with, okay? So x plus 7y equals 10. And then I'm going to plug in y for 1. Okay, so I'm going to plug in y for 1. And of course, that'll allow me to solve for x. So again, 7 times 1 is 7, equals 10. And then what I'm going to do is subtract 7 on both sides. So your 7s will cancel. And then I'm just left with x equals 10 minus 7 is 3. Okay? And that would be my other solution, my other solved variable. So my final solution is going to equal 3, 1. Because if I write it in the coordinate form, that's my x. We said x is 3, and then we said y is 1. Okay? So this would be my final solution right there. Okay? And then you can check this by plugging it into both of these equations, and you're going to see that hopefully it'll equal -12, and when you plug it into the second one, it'll equal 10. Okay? And it will work if you check it, if you try that out. All right? So that is a quick video on how to solve system of equations with elimination. And thank you for watching.